All right, in this video, we're going to look at some examples of limits involving infinity. We set out the some background results that we will use in the previous video. So if you haven't looked at the previous video, please do, which is the part 1 of limits involving infinity. Here we're going to go straight into examples. So I've got lots of examples here. We're going to do A to G, and then we're going to give you H to L to try. All right, so what I want to do here is I'm going to, instead of starting with A, I'm actually going to start with C, demonstrate and establish some results there, and then we're going to use that to go back to B and then A. So we have got in C the limit as x goes to infinity of 1 plus 2x minus x squared. What I'm going to do here is I'm just going to tabulate the behavior or feature of these terms as x goes to infinity, and then make some conclusions from there. So let's see what happens here. So x, in one column we're going to have x, in the next column I'm going to have the first term, which is 1. Then in the next actually row I'm going to have 2x, then I'm going to have x squared here, and then in the last row I'm going to work out the value of y. Okay, so and then we're going to make some conclusions from there. So suppose we start with x equal to 10. So the first term remains 1. 2x is going to be 20, minus x squared is going to be minus 100. So y is simply going to be the sum of these 3 columns. So we're going to have 1 plus 20 minus 100. So y is going to be negative 79. Then let's suppose that x is 100 now. The first one remains 1. This one is going to be 200. And the third row is going to be negative 10,000. Okay, so then y is going to be equal to 1 plus 200 minus 10,000. So this is going to be negative 9799. And then if x is 1,000, this remains 1. This is going to be 2,000. This is going to be negative 1 million. Okay, and the value of y is going to be 1 plus 2,000 minus 1 million. Okay, so it's going to be negative 997,999. Going to end this here. So the thing that I want us to note is the following here: as this is going to infinity, the constant is remaining constant. This is variable, it's also going to infinity. This is going to negative infinity. However, since this is a higher power than this one, the whole value of y at the bottom is dominated by the x squared term. So even though this is going to infinity, this one is dominating the whole value, so that the final value of y is also going to infinity. So the point here we are trying to make is that the behavior of this function as x goes to infinity is going to be dominated by the highest power of x. So you can see that like I was saying, this one goes to infinity, this one goes to negative infinity, but since this one is the highest power, then everything goes to negative infinity here. So the answer for this one is going to be negative infinity, simply because the highest power goes to negative infinity. Okay, so and that's generally going to be the case with these type of calculations. All right, so now let's go to B and then we'll go to A. So in B we've got limit as x goes to negative infinity to x cubed minus x plus 3. So limit as x goes to negative infinity to x cubed minus x plus 3. So in this case, the limit is going to be dominated by the 2x cubed term. If we can do this, allow me to do it like this. So this term is going to go to 2 times negative infinity cubed. And then based on the rules of arithmetic with infinity, this is going to be 2 times negative infinity. This is going to go to negative infinity. Okay, then in the first one, we've got 100 minus 7x. Now, if you like, this is 100x to the power 0. So the highest power is this one. So that is the one that is going to dominate the proceedings here. So it's going to be negative 7 times infinity. So it's going to be negative infinity. Okay, so A, B, and C is done. We're now going to go to D. So in D, we have got the limit as x goes to negative infinity of 4 plus 3x all over 5 minus x. Now, so in the previous video, we said for these ones, rational functions, the method one that we have that we can apply is to first divide everything by the highest power of the denominator. Okay, divide everything by the highest power of the denominator, and then do direct substitution. So that's exactly what we're going to do. Well, in the denominator, the highest power is x. So we're going to divide everything by x. It's going to be 4 over x. Here, 3 over x, 3x over x is just going to give us 3. We're going to have 5 over x here, minus 1. And then we're going to let x go to negative infinity. Now remember, we said reciprocal powers of x as x goes to plus or minus infinity go to 0. So this term is going to go to 0. This one is negative 3. It's going to remain negative 3. From our table analysis here, we've seen that as x go to plus infinity or minus infinity, constants just remain constant. So then in the denominator again, 5 over x will go to 0. And so this thing is going to go to 3. There is another method of working this out. Is actually a dominant term analysis. So it's a bit similar to what we established when we did from this table analysis. So in this case, we're going to say as x become big and negative, okay, become big and negative, or I think let's just say as x approach negative infinity, the rational function that we are investigating is this one. So here, as x become bigger and bigger but negative, the numerator is going to be dominated by the highest power of x again, which is 3. Denominator is going to be dominated by the highest power, which is x. The constants are not going to make an impact. Okay, so this is going to simplify to negative 3. Okay, I think there was an error here. From here, there should be plus, and so that should be negative 3. All right, and so since this is working out to a constant, then we conclude that the limit as x goes to infinity of 4 plus 3x all over 5 minus x is negative 3 from this method. Okay, so then we're going to go to D. Sorry, that was D, and we're going to go to E. In E, we have got limit as x goes to infinity of 3 minus 2x squared all over x cubed plus 2x minus 5. Using the first method, we're going to ask ourselves what is the highest power of x in the denominator, and I think you can see that it's x cubed. So we're going to divide every term by x cubed. So in the numerator, we're going to have 3 over x cubed, minus 2 over x. In the denominator, we're going to have 1 plus 2 over x squared minus 5 over x cubed. Then, as x goes to infinity, all reciprocal powers go to 0. So the numerator is going to be 0 minus 0. Denominator is going to be 1 plus 0 minus 0. This thing is going to work out to 0. Okay, using method 2, as x become bigger and bigger, our rational expression 3 minus 2x squared over x cubed plus 2x minus 5 is going to be dominated by, in the numerator, negative 2x squared, in the denominator, x cubed. Simplifying this gives us negative 2 over x. What does this mean? This means that the limit as x goes to infinity of 3 minus 2x squared over x cubed plus 2x minus 5 is going to behave like the limit of negative 2 over x as x goes to infinity, and the limit of this is 0. Okay, then we go to f. We have got the limit as x goes to negative infinity. The function is 3 minus 2x cubed all over x squared plus 2x minus 5. The highest power in the denominator is x squared this time. So we're going to divide everything by x squared. So it's going to be 3 over x squared. That's going to be 2x. It's going to be 1 plus 2 over x minus 5 over x squared. If we let x go to negative infinity, this term goes to 0. This one goes to, let's just do this. This goes to 1. This goes to 0. That goes to 0. So it's going to be plus 0 minus 0. So in the numerator, we're just going to have 2 times infinity. So this is going to be going all the way to infinity. Using the second method, as x go to negative infinity, 3 minus 2x cubed all over x squared plus 2x minus 5. The numerator is going to be dominated by 2x cubed. The denominator is going to be dominated by x squared. So this whole thing is going to behave like negative 2x. So what this means is that the limit of this thing, the limit of this rational function here, as x goes to negative infinity, is going to be the same as the limit of negative 2x. So that's going to work out to infinity. So that is our f. We are now going to go to g, which is going to be the last one we're going to do now, and then we'll give you an opportunity to try the last 5 before we can show you our answer. Okay, so in G we have got the limit as x goes to infinity of 6x squared minus 1 divided by 5x minus 2x squared. The highest power in the denominator is x squared. Dividing everything by x squared is going to give us 6 minus 1 over x squared. In the numerator, 5 over x minus 2 in the denominator. And the limit x goes to infinity, 6 remains 6. 1 over x squared goes to 0. 5 over x goes to 0. Minus 2 remains minus 2. 6 over negative 2 is negative 3. Then in method 2, we are going to say for large x, 6x squared minus 1 over 5x minus 2x squared is going to behave like in the numerator, going to be dominated by 6x squared, denominator going to be dominated by negative 2x squared, which works out to 3. And so what this implies, it implies that as x goes to infinity, 6x squared minus 1 over 5x minus 2x squared goes to negative 3. All right, so that sorts that out. So what we would like you to do is try the remaining 5 examples. So that's these ones here. So what you can do is just pause the video, have a go at these, and then when you press play, then you can compare with our answers. All right. We're now going to scroll down to our solutions of H, I, J, K, and L. Okay, so in H, we have got the limit as h goes to minus infinity of 4 minus 9x cubed. So here this expression is going to be dominated by this term, which is the highest power of x, and so that gives us infinity, because this cubed is going to be negative infinity. For hi, as x goes to negative infinity, the numerator is dominated by negative 9x, denominator is dominated by 3x. That simplifies to minus 3, so that tells us that that limit is going to go to negative 3. In this case, we're going to use the method of dividing by the highest power of the denominator. So we're going to divide by x. So this becomes 4 over x, that becomes 9x, becomes 3, that becomes 2 over x, and then as x goes to infinity, reciprocal powers go to 0. That becomes minus 9 times infinity, becomes 3, so this is going to work out to negative infinity. This expression as x goes to plus or minus infinity is dominated by 3x squared in the numerator, negative x to the power 4 in the denominator. So this expression as x goes to infinity just behaves like negative 3 over x. Negative 3 over x as x goes to infinity goes to 0. In L, highest power of the denominator is x cubed, so if we divide everything by x cubed, that's what we get, and then all the reciprocal powers go to 0, which is 2 of them here, so we're going to have 6 over negative 3, so that's going to go to negative 2. All right, thanks for watching. Hopefully this has been helpful. You can subscribe so that you get notified whenever we post new material. Thank you.